Hi everyone, welcome back to our YouTube channel BIM for Construction. So today we will discuss about the pipe and how you can draw a pipe with slope, and we will understand the basic in depth what is the meaning of slope. So let's start. So in our previous video we have discussed about the basics of Revit and its interface, use, filter, piping system, all of these things in our first tutorial first tutorial part of this series. So all the BIM, Revit, Navis, AutoCAD tutorial you will found in our playlist section. So as you can see here, I have drawn a model for a building. This is our drainage system. So we will discuss about how we can draw a pipe with slope in our drainage system. So for drawing the pipe, we need to use the PI command, and as you can see here, you have the available slope off option, slope up, down, and many of the things related to the pipe you can control from here. We will discuss one by one. So let's start with the slope off. I have chosen the 10 feet offset from the current level, which I can see easily in this section. Let's see how it works. So as I use the 10 feet middle elevation of the pipe while drawing from the ground floor, so when I put the dimension, you can able to see that with the help of DI command, you can able to see that the middle of the pipe is 10 feet from the ground floor level. So this is the middle elevation value which I choose when I drawing the pipe. So here you can see in the properties, the reference level is the ground FFL, top elevation is the 10 feet and 2 1/4 inch, middle elevation and the bottom elevation. So for the bottom it is 10 feet right now, because while drawing the pipe I have choose in the middle option. As you can see here, the spot level for the bottom is different, for the middle is different, and for the top is different. Right now the value of spot level is different because I have to change the reference to take it from the ground FFL. So when you change the reference level, it will become as per the it will measure the distance from the ground FFL level. So you can see here clearly the middle is 10 feet, the top and the bottom has different value from the ground FFL level. This will change, the top and bottom will change as per the pipe dia, and after that slope you can change here, right? If you want to draw a pipe with the slope up, and you can also choose the value of slope percentage like 1%, 2% or 0.5%. It depends upon the specification and the IPC rules. So as per the pipe dia, there is a rule to use a specific percentage slope percentage value. So you can see here the where we start the pipe it is 10 feet, and where we end the pipe it is 10 feet 1 inch above from the ground floor FFL. And when we change the slope percentage value, it varies. So for the 2% values, the pipe will be more up. For the 1% value, it will be less up than the 2%, and for the 0.5% value, it will be less up than the 2% and 1% value. So what we need to use, it will depend upon the diameter of the pipe, and it can be easily found in the IPC rules. And similarly, for drawing the pipe with slope down, you have to click on the slope down. That's time the pipe will go from up to down. So as per our direction of drainage, we will choose the pipe slope up or down. So always from our plumbing fixtures like lavatories, WWC, the soil waste will come out and go to the horizontal stake or the vertical stake. So you can see here the first pipe is that we drawn without any slope. Second, that we have drawn from our starting point and we have chosen the slope up, and the third one where we have drawn the pipe with the slope down. So in drainage we use the slope because the drainage system is a self-cleansing system, or we can say it is a gravity system. We do not require any pump from lavatories or WWC or water closet to draw the wastewater from system to the horizontal or vertical stick. That's why we use slope, so the water automatically from lavatories or water closet will draw to the nearby stick. Then here is a justification. Also you can see here, as here when we draw pipe, middle elevation option is available. So if you want to change it from that, whenever I put the 10 feet value, it will take the bottom of pipe to the 10 feet. So for this you need to change in justification. So right now I have changed the justification, and from here let me check again. So we have draw the pipe in slope. Let me draw the pipe without slope. Slope of justification we will choose bottom. Now we will again choose the 10 feet value. So as you can see here, now the bottom of the pipe is 10 feet from the ground floor, and earlier the middle is 10 feet from the ground FFL. So as per the justification, you can change the value. So this is the use of justification. Vertical justification, top, bottom, middle, anything you can choose. So with the 10 feet value, same, we have drawn the 3 pipes, and in each pipe we have taken the 10 feet value in the justification, but the justification is different for the first pipe, which is middle justification, for the second pipe bottom justification, and for the third pipe it is top justification. And again here you will find the horizontal offset. So whenever we use the PI command and we draw the pipe, so we have to choose the starting and the ending point. So from the starting and ending point, what we choose in Revit, it will take an offset of that value. Let me show you with example. Like I have put the 2 feet in the horizontal offset, and from center to center I have chosen. So now if I use the PI command and draw the pipe, so from that point it will take the 2 feet justification. So the horizontal offset, it will take 2 feet. So from here you can change the 2 feet value. It will take from the center or any other side of the pipe. So this is the use of justification. Automatically connect means if I draw the another pipe with the same level and I want to connect these 2 pipe with the T fitting, so whether they should connect or not, this will be guide through the automatically connect option. So if you don't want to connect 2 pipe, if you are drawing those at the same level, then they will not connect if you haven't choose the automatically connect option. Right now we have draw the pipe, both are at the same level, 10 feet from the FFL, but these are not connected when I draw the pipe. But when I have chosen the automatically connect, and as you can see here, the pipes get connected with the T fitting. So the system is totally, you can select with the tab. When you press the tab, all the system will get connected. You can see here in filter, 1 pipe fitting, that is T, and 3 pipes available there. So this can be done through the automatically connect option. Slope we have discussed, justification we have discussed, and the automatically connect we have discussed. Now move to the further. You can see here when I draw pipe in section. So you can see here the point of drawing pipe is available in the top, and in above pipe it is in the bottom, and in third one it is in the middle. So this is also you can choose. In the justify option you have to change, like for this pipe, the drop pipe option, you can see here the cursor is available from the top. So click on the justify, you can change it to the middle and then finish. Now the option is available from the middle of the pipe. Here it is available in the bottom of the pipe. So also you can change here from the middle and finish. So now you can draw the pipe by clicking on the middle cursor. So this can be changed through justify option in the section. Let's move to the ground floor plan again. So we have opened right now ground floor plan, that is our top and section and one 3D plan. Another is our connection. So whenever we drop one pipe or another, how it should connect. So first option we checked, add vertical, and second option change slope. Let's see how they connect when I choose the second option. You can see here the pipe will get in slope and connected to the bottom one pipe, and when I choose the add vertical, so add in this a vertical new pipe will be add between these two pipes. So through this you can choose as per your project or requirement. Offset connections. So automatically justification, slope, offset connection we have discussed. The slope value are available there, 1%, 2%. Tag on placement. This means whenever I draw a pipe, a tag will be placed on the pipe. So right now the size and the system type it is available there, means 90 dia pipe, 90 mm dia pipe and west pipe, it will be available there. If you want to change the WP abbreviation, you can go and change from your piping system. So this is the use of tag on placement. Whenever I draw the pipe, the tag will be placed on the pipe. Let's draw another pipe with a different dia. Again you will found that tag will be available there. So you can change the unit of a project and the tag as per your need. Like if you want it to be shown in mm or inch, you can do as per your requirement by editing or by changing the project unit. So this all we have discussed, the basics of drawing the pipe, offset, dia, and there is one option available, locks and unlocks. With the use of this you can lock the bottom or whatever justification you have decided. Like if you want to draw every pipe at 10 feet, by mistakenly you don't want to draw at another level, so you can lock the middle elevation justification from the lock button. So whenever you draw pipe, it will always be that selected value, and by unlocking you can change the pattern. So here are the basic notes what we have discussed till now. So slope setting we have discussed, slope up we have discussed, slope down we have discussed, and the value of slope you can show in percent, in 1 ratio 100 to 100 something, 1%, 2% something, as per changing the units. In the project unit you can change these settings. Tag on placement we have discussed, automatically connect, justification, all these things. So you can take those notes for your reference. And please watch our first video also, in which we have in detail discussed about how we will create the different pipe material and how we can create the piping system. Like if you want to create the different material, CPVC, UPVC, or PEX material for your pipes, you can create. And for the system also, like you want to create the waste system different, you want to create the gray water system different, you can create as per the piping system. And now how we can draw the vertical pipe? This is the first option. You have to choose the command pi, then you have to put the value and double click on the apply button. So whatever value you choose, the vertical pipe will take the offset from the ground floor like 2 feet and it will be drawn. Second option, draw pipe, then again choose the value. It should be take offset from the ground floor FFL and double click on the apply. Then again the vertical pipe will be drawn. This is our first option. And second option, you can also draw the vertical pipe in your section. So horizontal pipe we have discussed how you can draw, and also the vertical pipe how you can draw. So second option, you can directly go to the section, then again you will find draw pipe option and you can create in the section also as per your need. Slope off or slope up or down you can change also in the section view, and as per your selection the pipe will be drawn. So this all we have discussed with you. So the notes you can prepare as per your requirement. And also if you haven't watched our Revit family tutorial series, you can find in our playlist section. We have a very organized playlist in our playlist section for the AutoCAD, Navis, Revit series tutorial and ACC also. So these are the basic things related to the pipe system, and which are very useful when you are working on a drainage system of a building. And also most widely used material for the sanitary drainage, you will find cast iron pipe and PVC pipes and the UPVC pipe. These are the mostly used material of pipes for the drainage system. And for the water supply, PEX, PVC, CPVC are mostly used. As you can see here, this table is taken from the IPC. For the 2.5 inch or smaller pipe, the slope will be 1/4 inch per foot or 2%. And for the pipe dia 3 to 6 inch, it is 1/8 inch per foot or the 1%. For the 8 inch above, it will be 1/16 inch per foot and 0.5%. So as per your requirement, you can choose here. So and also there is one more presentation is there, 1:100, 1:50, 1:200. So presentation can be as per your project need, how you want to show the value of slope in your project. Right now I have drawn a pipe of 1 feet in my ground floor plan, and let's see when I put the slope percentage value for 1%, what changes I will found at the end point of the pipe. So right now 1% slope I have chosen. What it say, the 1/8 inch per foot, the pipe will have a change in the value of level. So I will show you with example in section what does the slope 1/8 inch or the 1% means exactly in this section. Let's see it. So right now 1 feet length of pipe I have drawn with the slope up, and when I measure the dimension, let's make it around a simple value 5 feet from the ground floor FFL, from where I have drawn my pipe. Let's change the UN. Right now I have taken the rounding to the more value. Let me change from the project unit. So as you can see here, I have taken the 1% slope, and what it what happened right now, when I draw the pipe, the level of that pipe from the middle to the FFL is 5 feet, and after the 1 foot length it will get 1/8 inch above from the FFL. So this is the 1%, and when I change it the percentage to the 2%, it will be around 1/16 inch change in the pipe after 1 foot. So this is the basic concept of our slope value. So why it is changing in 1%, 1/8 inch? Because if you convert 1 foot into inches, it will be 12 inch, and when you take the 12 inch 1% value, it will 0.12. So 1% of 12 inch is equals to 0.12, and when you divide 1/8, divide 1/8, it is also 0.12. So this is the basic concept of slope. So for the 2%, the rise or drop in the pipe will be 1/4 inch after every 1 foot length of the pipe. In simple term, we can say that if you draw a 100 mm length pipe with the help of 1% slope value, so after every 100 mm length, there will be a 10 mm change in the elevation of pipe. So this is how 1%, 2% works. From here you can change the presentation of the slope, like you want to view the slope in 1%, 2%, or you want to show the slope in 1:150 or in foot. You can change from here as per your project shop drawing requirement. So I think from here you can easily understand the slope concept. And if you like the video, please subscribe, share and comment for more. So let's start the summarizing video what we have discussed. Here we have discussed about the justification, automatically connect, inherit size, add vertical, change slope, slope off, up, down, tag on placement. We have discussed about the 1%, 2%, 0.5% slope, how we can change the representation of slope in our project, like percentage, 1:, or in degree, whatever you want to choose as per your shop drawing requirement. And what are the guidance provided in the IPC, what material we can use in a drainage system, all of these. Thank you guys.